Hello everyone. In this video I'm going to talk about our project Zero-RI5C Hardware Security Mechanism to Mitigate Classic Software Attacks. This project was submitted to the Xilinx Open Hardware Competition 2022. For decades, cyber attacks have been a major threat to embedded systems. Buffer overflow attacks have been causing serious security problems, and at least 50% of today's widely exploited vulnerabilities are caused by buffer overflows. So, what is a buffer overflow? A buffer overflow attack can be achieved through the exploitation of a memory region by giving an extra payload on an input buffer, overwriting adjacent data locations of interest by the attacker. With the constant presence of software vulnerabilities in complex systems, it is clear that the root of trust, the hardware, has the role to ensure the security of embedded systems, thus representing the last line of defense against all intrusions. As such, the main goal is to implement hardware security mechanisms for a target FPGA platform integrating an existing RISC-V soft CPU core. The mechanisms must be designed to thwart the following classical software attacks. Given the purpose of these 5 attacks, after studying the attack replication on KeyMU Sci-Fi V31 platform emulator alongside the Freedom Studio IDE, the fundamental aim that these attacks have in common is the arbitrary code execution through structure manipulation like the return address and function pointer. There are RISC-V mechanisms that are designed to monitor these structures. Having a great focus on detection of a change in execution path, control flow integrity is a mechanism presented to be the fittest for this matter. Our proposed solution is a module situated between the memory and processor, as a programmable logic in the middle. This approach provides great resource management, keeping intact the hardware implementations, facilitating the use of this module in various third-party core system-on-chips with great flexibility. For the implementation, the chosen soft core was an open-source implementation of the RV32Y instruction set developed by Ibex. For the integration of Zero-RI5C module with the Ibex simple system, it's only needed to connect the instruction address register as an input to the module, and lastly connect the Zero-RI5C signal to a core interrupt. To demonstrate, first we need to stimulate a table with values containing valid jumps. A sequence of instruction address was used in order to stimulate those signals. These values used by Zero-RI5C need to be extracted from the program. After detecting an attack, the Zero-RI5C signal will make the processor stay in a while loop indefinitely. For more information, please visit our GitHub. Thank you for watching.